So I'm going to run the physics department at UMass Dartmouth, and my first duty this evening is to thank the Last Round Bar and Grill and the staff working for it. More applause. So, if you don't know, the Last Round does open just for us on Tuesdays. Normally they're closed, and they charge us nothing for being here. So I encourage you to eat, drink, and then drink some more as our way of saying thank you and repaying them for their generosity. So tonight's speaker is Marc Kuchner from NASA, where he's an astrophysicist and the citizen science officer. Marc has degrees from Harvard and Caltech, and he's a research scientist with NASA who's worked on the James Webb Space Telescope, which has, the last year or two, made some amazing discoveries about the beginning of the universe and early galaxies. But tonight, Marc is going to be talking to us about opportunities for us regular people to participate and contribute to scientific research. So these are citizen science projects. So Marc, I will ask you to take it away.
You raise your hand if you saw the meteor, or if you heard the meteor that crashed into the bay on Saturday. You heard it? Are you going to go out there with a boat and try to find it? Or you can go try it? Yes? Is it 100 feet of water. What is it, 100 feet of water? 100 feet of water? Oh, you can die. That's it. Oh, it's easy. What's your name? Lenny. Lenny's got covered. He's only 100 feet of water. That's an easy document. Right. Okay. Anyway, good for you guys for hearing this, for paying attention to the science going on around you. This is what I do for NASA, is science that... Louder. Science is louder. Yeah, okay. So what I do for NASA is organize projects that require large teams of people to go do stuff, right? We call them citizen science projects, and you can get involved with them. And here is a QR code that takes you to our page that has 42 different projects where we need help for more people than we have in-house to get the job done. I have 3 stories, roughly, to share with you tonight. The first one is called the invertebrate feeding tank story, and it's about how I got involved doing science, how I became passionate about doing science. The second one is about an idiot named Georgie. What's his last name? Georgie Robeson, the idiot. The third one is about a hero named Danny Roylance. Okay, so buckle up. Invertebrate feeding tank story. I'm in high school in New York, which you probably know where that is. New York State decided to hold a contest open to high school students to solve New York State's energy crisis. Can you come up with a way to generate energy to rescue New York? David's my friend. 2 of us decided to enter the contest. Now the science that we proposed was pretty simple. We were going to generate electricity using ocean waves. Wave comes by, lifts up a float. The float is attached to a magnet. The magnet goes through a attached to a coil. The coil goes through a magnetic field, and that induces a current in the magnet. High school stuff, we were just really jazzed about it, okay? Plus, we're gonna solve the energy crisis for New York State. So, we gotta build something, this ocean wave generator, and demonstrate it to the judges. David has friends in the Coney Island Aquarium who hook us up with an invertebrate feeding tank. It's a giant fiberglass tank. It's about the size of a big jacuzzi. When it's empty, we could carry it up the stairs to the room in the high school. One of the science teachers gave us a back room that we could use to set this up. So it was pretty easy to fill with water. So we fill it with water, we put our magnets and our coils and our floats and stuff in. I slosh the water around, David measures on the meter. Oh, some electricity. David sloshes the water around. I measure on the meter. Oh, electricity. Hooray, we do our experiments, we take our data. Now it's time to pack the whole thing up, go to Albany to show the judges. I start bailing out the water, dumping it in the sink. Bailing out the water and dumping it in the sink. A whole free period later, we have not made a dent in the level of the water. It is still pegged exactly where it started. This is where the creative scientific problem solving comes in. We're gonna siphon out the water. So we go to Home Depot, buy ourselves a hose. When you buy a new hose, what does it look like? It's got that new hose smell. It's nice, tightly coiled in this perfect spiral. We bring home our perfectly spiral hose and we set it up in our lab room in the second floor of the high school. It's a beautiful spring day. One of those spring days when some teachers are absent doing whatever teachers do on spring days. And at least one English class is doubled up, so it has twice as many kids as usual because the other teachers. So kids are sitting in the aisles, it's packed. There's kids sitting on the radiator near the window. Also, on this beautiful spring day, teachers are beginning to crack open the windows to let the nice, fresh spring air in. Okay, so David's holding the one end of the hose. He gives me the thumbs up. I get the suction going. Before you know it, we're starting to drain that enormous tank. And we're headed to Albany. He's standing by the window, gently lowering the hose out the window. How's everything going over there, David? Looks great, Mark. It's the principal knocking at our door, banging at our door. What's going on in here? Open this door this instant. The two of you, explain yourselves. We had no idea that what was going on was downstairs in the English classroom below. Some poor kid was sitting on the radiator next to the open window, learning about the Great Gatsby or whatever it is they talk about in English class these days. And along comes a little green friend from upstairs. A perfectly coiled hose was coiling its way into their window. And I pictured for just like a few seconds, staring into the hose like, what is this nice green visitor come from above to speak to me? And then the hose spoke, and then I got in trouble. I didn't have to go to detention or get suspended or anything like that. And I think maybe I learned something from the experience. Because that day, our little science project, which before that was just the two of us, was fun, but it got even more fun, more mischievous, when everybody in the school was somehow involved. Now everybody knew about the project, and in a little way, we had touched everybody in the high school. Next story, the idiot Georgie Rose. Raise your hand if you're from New Jersey. That's my wife. Raise your hand if you are related to Georgie Robeson. I don't want to insult them. Georgie Robeson is a pampered kid in New Jersey. His father is a judge. His uncle's a congressman. His grandfather's a congressman. Goes to Princeton. Goes to law school. Probably gets whatever he wants. His family gets him a job as the Attorney General for the state, where he becomes famous for arranging for the death sentence of a young woman. Then, a friend of the family who happened to make a lot of money from contracts with the Navy gets him a job as Secretary of the U.S. Navy for Ulysses Grant, President Grant. We're talking about Grant's Secretary of the Navy. At the time, the US Navy was kind of in shambles. We had just gone through Civil War, right? And the ships that were left were kind of these retrofitted old cargo ships. Someone had just invented ironclad vessels, and Spain had bought one and parked one right in New York Harbor to show it off, right? Picture this, it has 5-inch thick iron armor all around it, right? It's bristling with guns, 18 cannons. It has a 2,400 horsepower steam engine. Okay, so probably Georgie looks at this battleship and he's thinking, Spain has a Lamborghini and I'm driving a Pinto. I'm going to buy myself some new battleships and Congress will just suck it up. He orders himself a bunch of brand new battleships, ironclad battleships, and he decides that my burger is here. Could you deliver that to my son at table 1 who is very hungry? Like, give me a fine. Thank you. Miles, you no longer owe me a fine. Where were we? Okay, Georgie decides he's going to get his own battleships like Spain, where there's parked this gorgeous battleship right in view probably of every woman he had ever wanted to impress at New York Harbor. And he decides, I'm just going to order them, and Congress is going to pay for it, and I don't care. So he orders the battleships. He figures Congress is not going to allow the US Navy to default on its bills, right? Congress, of course, in this country has the power of the purse. They tell the rest of the government how much money you're allowed to spend and what you're allowed to spend it on. So when Congress finds out that Georgie has overspent, they pass a law. They say, you do not get to spend money in excess of the budget that we've appropriated for. You can't go into a deficiency. The law is called the Anti-Deficiency Act. And it's to ensure that it has a good purpose. It's to make sure that agencies don't overspend. You can't overspend Georgie, plus you can't even get stuff for free in excess of what we have allowed you to get. You can't accept help from volunteers. Come back to that. Fast forward to this is how I almost went to jail part of the story. I'm a staff scientist at Goddard Space Flight Center, and I've been doing science for a while. I did astrophysics, I worked on designing a little part of the James Webb Space Telescope, I had for exoplanets, had a lot of fun. But I was looking for something new to do. And I heard about this stuff called citizen science. So scientists, teams of volunteers have been doing science for more than 100 years, right? So Edmund Halley, the comet guy, organized a group to go follow the eclipse of the sun, to go line up along the path of totality and record what the sun looked like during the eclipse. William Whewell organized volunteers, ship captains, and lighthouse keepers to measure the direction of the wind. This is how we first learned that storms take the form of cyclones, right? These counterclockwise, rotational, moving masses of air, right? We learned that because volunteers helped report the wind direction. So people were doing it for 100 years, but now the internet is here, and there are a million new ways to collaborate. You can gather people together on Slack, you can get people together on Discord, on Google, whatever, Teams, all kinds of different tools for collaborating. There are even these specialized tools coming into being, like Zooniverse, where scientists are posting lots of data on the internet and asking for people to help analyze it. So I wanted to get involved. So NASA had a mission, a budget mission, called the Wide Field Infrared Explorer. And, sorry, Wide Field Infrared Survey Explorer. And this is kind of a budget mission. It had measured the entire sky in the infrared and recorded 4 different bands of data on 2 billion sources all around the sky. And I estimated of those 2 billion sources, which were galaxies and asteroids and all kinds of things, about 6,000 objects hidden in those sources were going to be protoplanetary disks. So places where planets like Earth form, where it forms from a big cloud of gas and dust. I can't find these by myself, but maybe if I get help from volunteers, then I can look for these disks. Oh, okay, I gotta be louder. So, I get everything ready. I'm about to launch this citizen science project on the Zooniverse platform. Now, other people in the federal government have been starting to experiment with citizen science as well, and they're starting to look into things like the legality of it. And the night before, I'm about to launch this project, where I'm going to invite, through Zooniverse's email lists, about 2 million people to participate voluntarily in my federal government research project, I learned about the Anti-Deficiency Act. So now I have a choice. I have a kind of crisis. Am I going to get arrested for inviting people to go on the roller coaster ride of science with me, to experience the joy, the mischief, the quest of learning about the natural world together? I decided, based on my memory of high school, that maybe I wasn't going to get in trouble from the principal. I went ahead and I launched the project. And that takes me to my third story, the hero story about Danny Boyle. Okay, so we launched the Disk Detector project. And to launch the Disk Detector project, I have to upload a whole lot of data to the Zooniverse site. I grab images from the Wide Field Infrared Survey Explorer, thousands of them. Upload this enormous batch of data. My computer has been churning for weeks. It's hot. I can cook my dinner on my computer. And I figured I've uploaded so much data, it's going to be at least 6 months till I have to upload another batch. There's no way anyone could possibly get through it. Launch the project. Thankfully, I didn't get arrested. I go back to other projects and I wait. About a month in, I start getting these emails. Dear science team, this is Artman40. Everybody on Zooniverse goes by like a goofy code name they use or whatever. Artman40 here. I'm seeing a strange glitch where I'm starting to see the same object over and over again. So I email Zooniverse. What is going on? Why is Artman40 having to see the same object over and over again in this detective? Zooniverse says, well, this only happens if you run out of objects to classify. There's no way that's possible. Artman40 would have had been working like a full-time job on my project in order to get through all of the objects. But lo and behold, Artman40 has indeed. We look at the data, he's classified everything we have on the site. The next day I get another email. There's someone else who's classified everything on the site. And there's someone else, and there's someone else. It turns out that besides Artman40, who turns out to be a postal service worker in Czechoslovakia, there's also William, who is a internal medicine doctor in France. And there's a whole slew of folks from around the world who are super passionate about science. Right? No big surprise to you guys. So I get them together and I go, wow, you guys are amazing. You know, we have this observing run coming up on Friday. What object should we look at? Before you know it, there's a whole list of objects on my desk. This is the most important objects, these are the most promising, this is the science you could do with them. Oh, and by the way, some of them are in the southern hemisphere, and you're going to need a different telescope. One of the volunteers goes over to University of Cordoba and sweet talks the astronomers there into giving us telescope time to look at the objects in the southern hemisphere. Anyway, this group of super users, they are just incredible. And as time goes by, I start trusting them more and more. They're going on observing runs with me. right? We were writing papers together. One of those super users was a man named Danny Boyd. And I came to trust him so much that when a colleague of mine wanted to start a new citizen science project, I recommended that she work with Danny because he could help her set it up. It would be a great addition to her science team. So Danny and Professor Amy Lee go off and they start a different project called Burst Chaser. Burst Chaser, by the way, is a project looking at gamma ray bursts. Gamma ray bursts are the largest explosions in the universe. They are typically observed from about halfway across the visible universe. They are either black hole collisions or neutron star collisions. We're not quite sure what, but you can chart when the gamma rays arrive. You can do something called a light curve, and then the light curves are different shapes, and scientists are trying to classify what the different shapes of light curves mean in terms of what the progenitor is for the gamma ray burst. So this is the project that Danny goes off and helps Professor Lean start. A couple years later, I run into Dan. I meet him in person for the first time at a scientific conference. He's dressed up, he's wearing the sport jacket, and he's giving a presentation at the conference. And Danny and I were so excited to meet each other in person. And the second day of the meeting, Danny pulls me aside and says, I have something I really want to tell you that I never got to share with you all this time. Remember when you first met me back when we were doing this detective together? I was homeless. I'm a veteran. And I have strong PTSD. And I'm afraid to go into my bedroom because I'm afraid of the dreams I might have. I'm an alcoholic. And because I got to do science with you and your team, I learned to overcome my fears. I learned that I still have important work to do, and I better get on with my life. So I want to leave you with that. There are at least three reasons to do NASA science. One is you might like to get into mischief like me and David. And spray water on David's class. Another is you might be interested in the biggest explosions in the universe and the protoplanetary disks that form the Earth and things like that. And cyclones and so on. And then the third is you might just realize that there's a lot of important work to do. So come follow our QR code. Do one of the 40 different projects. We have 40 different projects online. They're in every division of NASA science, from earth science to astrophysics to heliophysics, planetary science. I think there's something for everybody. There are projects that you could do on your cell phone right now. There are projects that you can do with a laptop. You have your own telescope. We've got projects for you. Lots of fun things. Just don't go to jail. Thank you, everybody.
No, you can't eat your burger. You have to answer questions from our audience. So, thank you, Mark. That was fantastic. I am sure we have lots of questions from the audience. The only thing I would ask is for you to repeat the question so that people watching the video at home know what the question was.
Okay, sounds good. How do you know that a gamma ray burst is halfway across the universe? That's a great question. So first of all, what does it mean to be all the way across the universe? Then we'll get to the half part, right? Okay, so we don't know how big the universe really is, right? Let me just put that there. But we know that we can only see a certain distance. So we have this other thing called the observable universe, which is what people a lot of times talk about when they're talking about the universe, right? Like, the universe told me not to eat this French fry that's been sitting on the table. I don't know what else has been sitting on the table. So that's the observable universe I'm talking about. So now, how do we know they're coming from halfway across the universe? So that was just on average. So they're distributed more or less uniformly around the universe But on average, that means they're typically more like halfway across the universe. That's where they mean.
The observable. The
I-
observable.
The observable universe. Yeah. Now, sometimes you can find the progenitor for some of these explosions. So you get the gamma rays, and then you quickly pivot whatever telescopes you have at this thing, and try to figure out what else is there at that spot. And generally, there's a galaxy. And you can often measure the distance to the galaxy using Hubble's law, which tells us how much the light has been redshifted as a function of how far away the galaxy is. So the farther away a galaxy is, the more the spectrum of the light has been altered. The whole thing is shifted into the red because of the expansion of the universe, because of how much time has passed since the light was emitted, and how much the universe grew during that time. And more than you want to know.
No, but thank you.
Sure. People ask me about our volunteers. How do they compare to AI? Yeah. So everybody wants to know in general, how do humans compare to AI? So it's not sort of a unique question for me, right? It's like something that our species is struggling with right now. The majority of NASA's projects are not something that AI would necessarily be able to compete with. So like AI can't go out and collect a sample of phytoplankton, right? Sorry, no. So making physical measurements is something that we definitely need real life for. And the other projects have been at the forefront of the human-computer interface. So we've started adding different flavors of artificial intelligence and machine learning and neural networks to our projects back roughly in 2014. And we just today launched a project which is a unique new experiment in human-computer interactions called Galaxy Zoo Clump Scout 2, which is a project where an AI has looked at a bunch of images of galaxies and labeled clumps in them that appear to be star-forming regions. But it messes up about half the time. And so we show all the label images to humans, and the humans take the labels and fix them. They move them around. And then they send that back to the AI to improve the model. So there are all kinds of creative ways that humans and AI are interacting. Unfortunately, this is kind of a sad thing, I also got a paper which a volunteer sent me today, which clearly was written by AI, and I have to go have the unpleasant duty of explaining to this person that it's half hallucinations. So there's going to be some work to do as we sort this out over the next, probably for the rest of our lives. How big a problem is space trash, and is there a chance that the meteorite was not a meteorite? Space trash is definitely a looming problem, especially when people start talking about launching more constellations of satellites. So we've I don't know, low Earth orbit, right? So the orbits that are closest to the planet, which are most useful for a lot of different activities, we rely on a system of tracking space trash, space junk right now. We have a catalog of space junk in low Earth orbit, and we have to execute corrective maneuvers to avoid it all the time. Fortunately, higher orbits further away from the Earth are still relatively clean, but we're probably going to mess those up. I mean, unless we get ourselves together. And I think this is a place where we need to be proactive so we don't ruin our own opportunities, so we don't muss our own clear water. And is there a chance that the meteor that broke up in the atmosphere near Boston this weekend, is a chance that was space junk? I think the answer is no. I can just say clearly no on that one. Because it came in, we know more or less the speed that it came in, came in around 75,000 miles an hour. And the Earth's orbital velocity around the sun is about 66,000 miles an hour. So that says to me that it was not moving along with the Earth. Its orbit was quite different from the Earth's. In fact, I think we can even probably say that it's not an asteroid based on that. Asteroids tend to have more circular orbits like the Earth's. This is probably a comet. And that hangs together with the idea that it seems to disintegrate in the atmosphere, because a comet landing in the atmosphere really falls apart and vaporizes when it gets to the atmosphere. Good question, though. Yeah, what about SETI at home is the question, right? That's the project. So there's a whole suite of distributed volunteer computing projects where a science team will take a computing problem and they'll chop it into pieces and they'll send it out to you, and you could run it on your PC as a screensaver sometimes. And one of the projects that got popular is this project SETI at home, so search for extraterrestrial intelligence. And here what people are doing is you're pointing radio telescopes at the sky, scanning, and looking for signals that look like they're not noise. They look like they're made by something intelligent. So they have to, they have to decode the signal and check to see whether looks like it's a earthly radio signal, or whether it's lightning, or whether it's some other kind of human-made signal. And this project takes a lot of computing power, and so they farmed out the project to volunteers. And this is not the kind of thing that we do a lot of in my program, because I tend to think that the most valuable use of volunteers is their own creative intellect and enterprising spirit. But some people have gotten very serious about their distributed volunteer computing projects and built their own computer clusters just to solve these problems. And I have great respect for those folks. And SETI at home is still going on. In fact, there's a whole group of this kind of project that is run out of Berkeley called BOINC. I forgot what BOINC stands for, but it's this whole fleet of different projects. And if you're into computing and donating computer time to science, there are lots of cool projects to get your computer involved in. What kind of citizen science projects are out there that are related to climate change? Right. So there are lots of good ones. So one of my favorite projects at NASA that's relevant to climate change is something called mosquito habitat mapper. So as the climate's been changing, the homes and the migration patterns of mosquitoes have been changing, and people are finding mosquitoes of different varieties in different places where they weren't before. So in mosquito habitat mapper, folks are going out and they're looking at puddles of water and checking to see what kind of larvae are living in the puddles of water. And that helps us locate where different kinds of mosquitoes are. And this is a way to contribute to saving lives, because mosquitoes carry things like dengue and malaria and Zika. I'm sorry, they don't carry dengue. They carry malaria, and they carry Zika. So that's the mosquito habitat mapper. It's on Globe, and is a NASA sponsored podcast. There are several other projects that we're doing. We had a project that was looking at how kelp has been responding to climate change. We have a project called Land Cover, where people are looking at just how is land use evolving and how does it affect our climate. I can send you a list of some good ones that I think will inspire you. Thank you. Oh, great. How do schools, especially middle schoolers, get involved with these projects? Yeah, that's great. So the GLOBE program, which does these climate-related projects, has had lots of success working with students. And that's something that I was doing in middle school class 2, NASA GLOBE. And you can find it, just follow my QR code.
And there's a woman behind the pillar who has a question.
The question is, how do you train people? And the answer is that all of these projects, okay, so we have a handful of advanced monkey projects, which we share with specialized communities. So for example, we have a project that's all about being a ham radio operator, right? I'm not a hand radio operator, so I wouldn't be an operator, so I wouldn't be able to do the project. But community of hand radio operators is really enthusiastic, and we're so grateful for that. But most of our projects come with all the training you need. So you go to the website, and there's a tutorial, and you take the tutorial, and in about 10 minutes you know what you need to know. And if you forget, they also come with field guides, so you can remind yourself. Do you have a favorite topic area? I can recommend a project just for you. Do you like asteroids? I'm kidding. Actually, the NIH, I mean, there's a wonderful history of medical research done with volunteers, right? But maybe you want to do something other than what your day job is. No, but seriously, if you have, try Clump Scout. The one we just launched. I'm always most excited about the most recently launched one. And Galaxy Zoo Clump Scout 2. Just launched it today. It looks like it's a lot of fun. I'm going to take a second to brag, because people in the room here have our professional scientific experience. We have more than 650 of our volunteers have now co-authored scientific papers because of their volunteer work with us. You would be one of those? That's the bar. Is there a project that I would go to jail for? And that question could mean one of two different things. Like, did I do something that was so bad already that I probably will go to jail? Is that the question? Or is there a project that I love so much that I'd be willing to sacrifice my free time and my opportunity to have a close, loving relationship with my family who's sitting right behind you in order to do this science project? You want to ask it again? Well, here's one. So we have multiple projects about near-Earth asteroids. You know what those things are? Yeah, so they had these things on Earth called dinosaurs for a while, and then an asteroid came, and now we don't have dinosaurs. And there are more asteroids like that out there, right? And we don't know where all of them are located. So we have multiple projects that are searching for near-Earth asteroids. And we have at least 4 of our volunteers who have had asteroids named after them because they discovered them through this project. Sorry, family, I'm ditching you. Go and ask for help. Any projects involving ticks? Oh, we should have projects involving ticks. I can't think of one, so we had... I mentioned phytoplankton, I mentioned mosquitoes. Oh, what other little critters? We're not really like the little critter space organization, we're just like the space organization. Birds, great topic for citizen science. Have you ever done the Christmas bird hunt? Yeah. So Cornell University has all these great eBird projects about birds. So the closest that NASA has for a bird thing is that we ran a project that was about listening to the sounds of nature during a solar eclipse, so the 2024 eclipse. We had people out there making recordings of how mostly insects responded to probably how ticks responded to the eclipse. Got really extra bloodthirsty. We found, I don't know yet. I think they're still processing the data. We're kind of slow. Gina and Gina's friend are asking, are there particular locations that are especially active in NASA citizen science? So I don't have perfect knowledge of where everybody is participating from. And that's for a good reason. We try to make the barrier to participation as minimal as possible, so we don't ask everybody for their location. I do know that we have, in the United States, a particularly large group of participants in Alaska and in Wyoming. I know that in terms of countries, our citizen science is especially popular in the United States and in the other English-speaking countries. Go figure, right? So UK and Australia are big contributors. India and Brazil also have space programs and are interested in NASA stuff, and they often show up on our radar. What are the big accomplishments that I point to demonstrate the value of citizen science? NASA volunteers have discovered most of the known comets. They've discovered every single example of material that has come to our planet from beyond the solar system. Every single interstellar dust grain is what I'm talking about. There was an entire issue of the journal Meteoritics and Planetary Science devoted to analysis of those 8 dust grains discovered by NASA volunteers. At one point, they had discovered most of the long-period exoplanets, though that's been overtaken. And just announced a couple of weeks ago, NASA volunteers have discovered more than half, so most, of the objects called brown dwarfs. A brown dwarf is this ball of gas. It's about the size of Jupiter. Doesn't have enough mass to be considered a star, and is too massive to be considered a planet. And there's about one of these for every 3 or 4 stars. If you had infrared eyes and you looked at the sky, you would see brown dwarfs everywhere. Most of them were discovered by Apple.
So I think that's a wonderful question to end this evening's formal Q&A with. So let us thank Marc again for his wonderful presentation.